booklet. So from page C.1 booklet. No, not P.1. I have so many documents called C.1, P.1, so on and so forth. But anyway, yeah, so in your booklet, you should see right at the end, there's like a module review.
Yeah.
We're just going to be picking questions from there today.
All right.
So what page is this? This is page 68.
Yeah.
Also, did you get around to completing all of the last inquiry, the last concept check?
Oh, I didn't.
Okay. Do you want to go through that?
Yeah.
All right. Do you just want to go through them together, or would you like to attempt them first and then check with me?
Yeah, I'll attempt them.
Mm-hmm. All right, no problem. Just let me know, I guess, when you finish them.
Yeah.
I have a question. What is this, week 4 or week 5?
Week 5.
Okay, so we might, yeah, we'll probably end up getting halfway through module 2 before the year ends, and then before I don't know when the center wraps up, but I don't actually finish when the center wraps up.
Oh, okay.
Yeah, so I go for well, I can do a maximum of 2 weeks afterwards before I go away for Christmas.
Yeah.
So yeah.
All right. Okay.
So I would like the plan to be that. Oh, it depends how far we get into module 2. If we're on the brink of finishing module 2, I'll have the extra lessons with you and just complete module 2. But if not, well then I guess we'll just kind of leave it there.
Okay. All right.
We'll discuss this later on. Sorry, I was just thinking out loud.
Okay, that's fine.
Okay.
I'm not exactly sure how to answer question 2.
Oh, okay. So what did you get for question 1?
So a hydrochloric HCl has a polar covalent bond, while O2 has a non-polar covalent bond. And polar covalent bonds have higher melting and boiling points compared to non-polar covalent bonds due to their stronger attractions.
Yeah. What type of bond though is it? Like what type of intermolecular bond occurs?
Um.
You always need to state which one it is.
Oh, okay.
Yeah.
London dispersion, is that?
Yeah, all of them experience just call them dispersion forces.
Oh,
All of
okay.
them experience dispersion forces, but what is special about HCl?
Oh, it's a hydrogen bond.
Mm-hmm.
Oh, okay. So that means it's a stronger bond
Yes.
due to its like uh magnetic attractions, I guess.
Electrostatic. You never
Yeah.
talk about magnetism here.
Yeah, okay.
So the other one is that it experiences dipole-dipole interactions because you said that HCl is polar covalent. Yeah.
Yeah.
So because it's polar covalent, well, anything that's polar is going to be a dipole because if something is polar, that means that it has a positive end and a corresponding negative end.
Okay.
Does that make sense?
Yeah.
Okay, but what about hydrogen bonding?
Hydrogen bonds, so hydrogen is a positive ion, and that kind of attracts to the negative ions, like for example, like oxygen, nitrogen, and fluorine, especially.
Yeah. Well,
Yeah.
not especially. It's those three specifically.
Oh, okay.
Yeah,
Only those three?
only those three. Yeah.
Oh, okay.
So hydrogen bonding wouldn't occur here in HCl.
Oh, all right. Okay.
Yeah. So hydrogen bonding occurs when hydrogen bonds to the most electronegative elements, full stop. And those three are in
Oxygen,
order. Beg pardon?
oxygen, fluorine, and nitrogen.
Yeah.
Yeah. Okay.
But in order of like strongest to weakest, it's going to be fluorine, oxygen, nitrogen. So it just goes right to left.
Okay. Okay.
So using that little explanation, do you think you can tackle question 2, or would you still like my help?
I'd still like some help.
Okay. If a substance is pure covalent, well, then that means it's neutral overall, doesn't it?
Yeah.
So if it's neutral overall, what intermolecular forces is it going to experience?
Um, dispersion.
Yeah, all of them experience dispersion no matter what. Is there another one?
Uh, dipole, dipole.
But it's neutral all over.
Oh, yeah, I don't know.
It's just going to be dispersion.
Oh, okay.
Yeah, so that's kind of the catch. So remember, if it's pure covalent, well, that means it's kind of neutral everywhere. And because it's neutral everywhere, well, doesn't that just basically mean that there's no polarity, so there's no dipoles?
Yeah.
You sound unsure.
Yeah. Um, but I
Would you
don't
like
understand why.
to be cut?
I don't understand why though.
Oh, well, I can draw it. I'll try to do a little quick drawing. Um, so the idea is, like, what is a neutral substance? Like O2, yeah?
Yeah.
So O2. If we look at the electrons of O2, so typically they each have 6. So if you were to draw the Lewis dot diagram, they would each have 8 because they're going to share a pair.
Yeah.
So because they share, do we have a positive ion and a negative ion?
No.
Okay, so is there going to be a charge? Is there going to be a dipole, or is it just going to be neutral or overall?
Neutral.
Okay, so because it's neutral, let's look at the 3 different types of intermolecular forces. The first one is going to be, well, dispersion forces. Everything has dispersion forces, so we'll ignore that one. The next one is dipole-dipole interactions. Is this a dipole if the electrons are being shared?
No.
Exactly. So there's going to be no dipole-dipole interactions. And hydrogen bonding is just dipole-dipole interactions between hydrogen and those other 3 elements.
Yeah.
So does that answer your question?
Yeah, okay.
So would you like me to continue?
Yes.
Okay, no problem. So if something is pure covalent, it means the electrons are being shared, so there's no charge. So that means that, well, it's going to be, there's no charge, so therefore it's going to be dispersion forces. Now for polar covalent and ionic, because remember they both are dipoles because they both have polarity.
Yeah.
So that means that they're both going to give rise to dipole-dipole interactions. And if they have hydrogen and oxygen or fluorine or nitrogen, hydrogen bonding is also going to occur.
Okay.
What are you thinking?
I'm trying to answer the question now.
Okay.
Yeah.
Would you like me to kind of chime in, or do you want to do it on your own?
Yes, chime in, please.
Oh, okay. So if I were to answer this question, I would just basically say, if a substance is pure covalent, it doesn't have a polarity. It's not a polar bond.
Yeah.
So therefore, it's just going to experience dispersion forces.
All right.
If a substance is polar covalent or ionic, it has a difference in polarity, which means that there's going to be dipoles. So they're going to experience dispersion forces as well as dipole-dipole interactions. And if they have hydrogen or oxygen, nitrogen, and fluorine, then hydrogen bonding also occurs.
Oh, okay. Okay, I understand now.
All right, good. I'm really happy.